Now that we're approaching the end of our unit on parallel lines, it's time to look at some more complex problems. In this problem, we have two algebra expressions. We have an x and a 2x minus 120, but we also have a p and a q. I think it's important to highlight the information that we know and do what we have always done, which is label our b's and l's. Okay, so there's my top neighborhood, and there's my bottom neighborhood. And if you look at the two algebra expressions that we have, they're both b's. So we know what to do with those. We know to make b equal to b. And we can solve this by hand or solve it in the Desmos calculator. We're going to get x is 120. So if we plug that in here, it'll just be 120 because that's just x. And here, 2 times 120 minus 120 is 240 minus 120, which is also 120. So that's not so bad. We can do that. But that doesn't answer completely our question of what is P and what is Q. We can tell that P and Q are L angles. So this isn't a horrible situation to be in. We know that B plus L has to equal 180. And we know that our B is 120. So most of us just go ahead and subtract those out. And that leaves us with 60 for each of the L angles. And the second choice, the measure of angle P equals the measure of angle Q, which equals 60. Now this problem, I think, is actually more challenging because we have a y variable and an x variable. And the thing to remember when you have more than one variable is that you cannot put them in one equation. So let's start off by labeling BB, LL, BB, LL. And let's highlight what we know. We know, oops, that's a bad highlight color, sorry about that. Let's do a yellow highlighter. We have a B, which is a y variable term. We have a B, which is an x variable term. And we have a 68, which has no variable in it. So that could be really useful for us. Now, in order to solve equations, we have to set up one equation for x and one equation for y. So we are going to need, because x is a b, right here, I'm going to solve for x first. We're not going to be able to use this because it has a y in it. So we're going to need to use the L. And we're going to need to use the equation b plus L equals 180. For now, we're just going to hold on to this separately. We'll use that when we have to solve for y. So our b is 2x minus 24 plus our L, which is 68, and that equals 180. And I'll have that solved in just a second. That looks like it's going to be 68. Now, if we want to solve for y, we can use the 68 and the y term. And notice that there also will be in an L. So we can set that up for y minus 16 plus 68 equals 180. And we can put that into our Desmos calculator. Now, what I would probably do is still put that into the Desmos calculator as an X variable, simply because Desmos does better with the X variables. But then I'm going to call it Y equals 32. And we could check these. We could plug these in to see if we were correct. But that's why these problems are more difficult, because we have an X variable to solve for and we have a Y variable to solve for. And we have to do it with two separate equations. Here's another one. This one's even worse. Okay, so I'm going to point out the parallel lines. That's good. I'm going to show you that we're going to need to do BBLL 3 times, because we have 3 parallel lines. So we have 3 neighborhoods. We have a top neighborhood, a middle neighborhood, and a bottom neighborhood. Now we're going to need to highlight what we have. I have a 60, that's an L. I have a 3x plus 15, that's an L. And I have a negative 5y minus 10, that's an L. So in this situation, everything is an L that we need to deal with. So let's solve for x first. We have 3x plus 15, and we have 60. We're not going to use this right now because it has a y variable in it. We don't want to mix the variables. So because I have an L and an L, I'm going to say L equals L, or 3x minus 15 equals 60. X is 15. Now when I want to solve for my y variable, I'm going to remember, hey, this is also an L. So I can still use my L equals L relationship, but now I'm going to use my y expression. And I'm still going to use that 60. That 60 doesn't have any variables in it, so it's very helpful. So we'll have negative 5y equals 70, and we'll get negative 14 for y. And there we go. So we just have to remember, if we look at the picture, we see more than one variable, we're probably going to need to do them each separately. I'm going to highlight those anyway, and I'll put my P's and L's back in. My apologies. So this is a B, this is a B, so that makes that a no. So what we're going to end up doing is having to do the same thing we've done in the other problems, where we've set up an equation for x using the 3x and the 120, b equals b. X is easy to solve for here, but you can always use your Desmos calculator. And then we're going to solve for our y variable with a separate equation. And we're going to look at that and go, oh, look, y is actually, the 6y is actually in an L angle, and the 120 is a B. So I'm going to use the B plus L equals 180. And so my B is 120. My L is 6y minus 12, and that adds up to 180. And we'll get that solved. And divide, no, I'm sorry, 108. I believe we get y is 12, if I'm not mistaken. 180 minus 108 is 72 divided by 6. Yes, that's 12. Just double checking my answer there. So that's how that works. Now this problem doesn't have any instructions. And it doesn't have any variables. If you look at what we have, grab my highlighter, we have a 122 and we have a 58. We have information about line K and line M. We have no information at all about line L. None. So line L, it's as if it's not even there. And I suspect what this problem is looking for is for us to tell them it's K parallel to M. I'll put a question mark. And it might be. But let's fill in our vertical angles. The vertical angles. Now we have to fill in our linear pairs. So 180 minus 122, 58, okay. So there's that top neighborhood. And that means that 180 minus 58 will also be 122. We don't have to do subtraction twice. And what we need to do is we need to compare the two neighborhoods. So if you compare those two neighborhoods, look at the numbers, look at where the numbers are. Are they in the same exact place? And the answer is yes. These two lines are parallel because their neighborhoods are identical. Now here is a much more complicated version of that problem, but it's not really any more difficult. Now what I'm going to try to do is make this a little, no, I can't make it any bigger, I'm so sorry. But what I'm going to do is I'm going to fill in all the neighborhoods with the vertical angles. So here's going to be my 70. Now 180 minus 70, let me write that over here, is 110. So we need a 110 and a 110. So that's our top neighborhood. We want to try to find a match for that neighborhood. I see a 110 down there. We can try to fill that in. Let's do 110. 180 minus 110 is 70 and 70. So the question is, do these two neighborhoods match? Does the neighborhood for W match the neighborhood for Y? And it does. The 70 and the 110 are both there, and they're in the same location. So the corresponding angles are the same, the alternate exterior angles are the same, so forth, so on. But now we got to check, and let me switch colors here. Now we got to check the other neighborhoods. This neighborhood has an 80, 180 minus 80 is 100. So these linear pairs are going to be 100. So that's our second neighborhood. And I see down below, that's our X neighborhood, if you will, that this one also has linear pairs of 80, vertical angles of 100. It looks like X and Z match. So what we say is W, let me put that back in black here. W is parallel to Y. And then for the other two, we say X is parallel to Z. And that just happens to be choice F. And that's a really good problem to be able to say, hey, which lines are parallel? Kind of a different kind of problem than what I showed you at the beginning of the video, but there are a lot of different kinds of more complex problems.